This deep dive is brought to you by Triple Automation, your Canadian partners in turning complex shop floor challenges into simple plug-and-play productivity. Welcome, everyone.
Glad to be here.
So today, we are taking you straight onto the manufacturing floor. We're digging into this really fascinating white paper titled Beyond the Paycheck, the Real ROI of Collaborative Automation.
Yeah, it's a great read.
It really is. And our mission for this deep dive is to basically completely dismantle the traditional and honestly kind of incredibly narrow way that businesses calculate the value of shop floor robots.
Right. It's way too narrow.
Exactly. We want to uncover the massive hidden financial value of collaborative automation, or, cobots as the industry calls them.
And I think we really need to start by looking at a critical shift in perspective here. Right now, when plant managers or facility directors evaluate automation, they tend to get stuck on a very simple but, well, ultimately flawed math problem.
Yeah.
The text actually refers to it as payroll math.
Right, that classic formula. You take the upfront purchase price of a robotic arm, you divide it by the hourly wage of a manual operator, and you just figure out how many months it's going to take to break even on that labor offset.
Exactly.
I mean, it seems super logical on the surface.
It does seem logical, but the source material points out how universal this blind spot is across the whole manufacturing sector. That basic payroll math, it just misses the vast majority of the financial picture.
Right.
Like if your facility is only looking at wages, you are severely underestimating the actual return on investment.
It's like calculating ROI just on hourly wages is like judging the value of a smartphone strictly by how many long-distance phone calls it can make.
That's a great way to put it.
You're completely ignoring the camera, the internet, the apps. You just miss the entire ecosystem of value.
Spot on. And to understand that broader ecosystem, the white paper suggests we have to look past that hourly wage and examine the first major blind spot businesses have, the cost of human fatigue versus machine precision. We really need to look at the physical reality of a standard 8-hour shift on a production floor.
Oh, man. It is grueling work. We're talking about human operators asked to perform highly repetitive, physically demanding tasks for just hours on end.
Right.
That might mean applying this incredibly precise bead of sealant along a car part or tending a CNC machine. And for anyone not living in a machine shop, that's a computer-controlled cutting or milling machine.
Yeah, exactly.
So you're constantly loading and unloading heavy metal blanks into this machine, just over and over again.
And, biology just dictates that fatigue is naturally going to set in. No matter how skilled or dedicated or well-trained a worker is, they are just not going to be as sharp at 4:30 p.m. as they were at 8 a.m.
Right, after that morning coffee wears off.
Exactly. Their muscles tire, their focus drifts for even just a microsecond. And in manufacturing, that late afternoon fatigue translates directly to micro errors.
So a fraction of a millimeter error when you're cutting or sealing, that can ruin an incredibly expensive piece of raw material.
Oh, absolutely. Suddenly, a high-value aerospace component or a custom automotive part, it just became scrap metal.
Just because someone's hand cramped.
Just because they're hand cramped.
Okay, but I have to jump in here and push back a little bit on the scale of this claim.
Sure, go ahead.
I mean, I get that nobody wants a bin full of scrap metal, but is saving a fraction of a millimeter on a cut really generating that much more profit than just saving a worker's hourly wage?
It really is.
Like, is the math genuinely that skewed? It just feels like we might be exaggerating the cost of a single mistake.
Well, let's trace the life cycle of that single scrapped part to see the real cost. It isn't just the loss of the raw material, though, titanium or specialized alloys can be hugely expensive.
Right, true.
But you also lose all the energy and the time it took to get that material to that specific point in the assembly line. And then you have to factor in the rework hours.
Okay, so what does that rework actually look like on the floor, like practically speaking?
Well, a worker has to physically remove the ruined part. A quality assurance inspector has to log the failure.
Ugh, lots of paperwork.
Yeah, lots of administrative drag. And then someone has to transport that heavy part to a scrap bin, pull brand new raw material from inventory, and start the entire machining process over from scratch.
Wow.
So that single fraction of a millimeter mistake creates this cascading wave of financial waste that just ripples through the entire supply chain.
Okay, I see. So you're looking at a complete bottleneck. It eats up admin time, physical labor, machine time. That adds up fast.
Exactly. And the white paper makes a really interesting claim here about collaborative systems changing this specific dynamic. It highlights the JK Cobot series, which is distributed by Triple Automation.
Right.
According to the text, these systems maintain mathematical precision from the first minute of the shift to the absolute last. They just don't experience that 4:30 p.m. biological dip.
So by virtually eliminating that late shift human error, a facility just eliminates the rework hours and the damaged inventory altogether.
Yeah. Manufacturers are basically injecting pure profit directly back into their bottom line, starting on day one. It's not some, future projection based on a 5-year labor offset.
Right.
It is immediate, quantifiable waste reduction.
So you're essentially plugging a massive leak before you even start worrying about the speed of the boat.
I like that. Yes.
That definitely makes the ROI calculation much wider. But this brings a logistical question for me.
Okay.
If these collaborative robots, these JK systems, are this incredibly precise, you'd naturally assume they are massive, delicate instruments, right? How do they actually survive on a gritty, chaotic shop floor without getting damaged or, worse, hurting somebody?
Well, historically, you would be building a fortress around them. Traditional industrial automation required massive, permanent steel cages.
Right, the big safety fences.
Yeah, you had to keep human workers physically separated from high-speed, dangerous machinery.
And the friction of installing those cages must be enormous. You can't just drop a steel cage into the middle of a working factory.
Oh, no, not at all. You literally have to drill into the concrete. You have to shut down production lines for weeks just to install the safety infrastructure.
That's crazy.
And furthermore, they consume a massive amount of floor space. Real estate in a manufacturing facility is incredibly expensive, and you are dedicating a large percentage of it just to empty space inside a cage.
And I imagine it locks your facility into a single, rigid workflow. Like, if next year's product line is 10% larger and requires a new layout, you have to literally tear down welded steel fences to reconfigure your floor plan.
Yes, exactly.
That sounds like a total logistical nightmare, especially for a small or medium-sized enterprise that's just trying to stay agile in a fast market.
And the text points out that this rigidity was actually a massive barrier to entry for smaller manufacturers. However, Triple Automation's collaborative solutions bypass this entirely. They are fenceless, they're compact, and they're inherently safe.
That's because they have built-in force sensors, right? Like, if the robotic arm bumps into a person walking by, it just immediately freezes.
It stops completely. And because they don't require cages, they can be integrated seamlessly into an existing floor plan.
Wow.
A facility doesn't need to shut down operations or incur these massive real estate expenses to accommodate them. You can essentially just roll them up to the workstation where you need them, lock them in place, and turn them on.
Which leads to a scenario mentioned in the source material that, frankly, sounds like science fiction to me, but is apparently a standard capability now.
The ghost shifts.
Yes. Since you don't need the safety cages and the robots are inherently safe to just leave running, they enable what the industry calls lights out, or semi-unattended manufacturing.
It represents a massive shift in how business owners view their production capacity. Just imagine the human workforce clocks out at 5:00 p.m.
Okay.
Instead of the factory floor going entirely dormant, you allow a cobot to continue tending a CNC machine or packaging finished goods for an extra 2, 3, or even 4 hours into the evening.
It's like cloning your factory floor for a few hours a day without paying a dime in extra rent.
Exactly.
You literally lock the doors, turn off the lights, go home for dinner, and the cobot is still in there working.
Just think about the return on investment for that ghost shift. That extra throughput, those extra pallets of finished goods, represents pure revenue generated without adding to your daily facility overhead.
Right, because the factory isn't paying for extra heating or extra lighting or evening shift wage differentials.
Exactly. You are stretching the productive capacity of the real estate without stretching the operational budget at all.
Okay, so we've got robots saving money by eliminating scrap metal, and we've got them actively generating new revenue in the dark during these ghost shifts.
Yeah.
But if robots are running unattended and taking over all these high-precision tasks during the day, we have to ask the natural next question here.
The human element.
Right. What happens to the humans on the floor? Because I think the immediate cultural assumption is always, automation equals job loss.
And it's a fair concern, but the source text argues the exact opposite. It highlights human retention as perhaps the most surprising ROI metric of all. Investing in collaborative automation actually protects a company's most valuable asset, its people.
By taking away the physical tool of the work, I assume. The white paper mentions on-robot end effectors.
Yes.
And these are basically the hands of the robot that attach to the arm, right? Like they can grip items, drive screws, or run a sander.
Yeah, they're the adaptable tools at the end of the arm.
So if a facility uses those robotic hands to offload the dirty, dull, and dangerous tasks, they are fundamentally changing the daily lives of their workforce.
Completely. We are talking about removing the heavy lifting, the awkward twisting, and the repetitive strain motions that just slowly break down a human body over years of manual labor.
Yeah.
Shielding a team from long-term musculoskeletal strain and workplace injuries alters the entire economics of an HR department.
Well, sure. If fewer people are throwing out their backs lifting 40-pound metal blanks all day, the company's workers' compensation premiums must absolutely plummet.
They drop significantly. And additionally, it reduces everyday absenteeism. Workers aren't taking random Tuesdays off because their shoulders are severely inflamed.
Right, right.
The text argues this leads directly to higher employee retention, which is critical in what is currently an exceptionally competitive labor market for skilled trades.
Okay, I understand the value of saving their shoulders.
Yeah.
But I have to push on the actual mechanics of this transition. You are taking a worker who might have spent 20 years doing manual labor, literally just lifting metal and packing boxes, and suddenly you're telling them they are a, quote, robot supervisor.
Right.
How does a worker with zero coding experience actually do that? Do they need to go back to school for a computer science degree just to keep their job on the floor?
No, and that is the brilliance of modern collaborative automation. It's a vital part of the HIW behind this technology.
Okay, lay it on me.
The interface isn't some complex, intimidating wall of green code on a dark monitor. It is highly intuitive. Often these cobots are run from a standard tablet or a touchscreen using really simple drag-and-drop menus.
Oh, wow. So it looks more like a smartphone app than a software engineering terminal.
Much more like an app. And furthermore, many of these systems feature kinesthetic teaching.
What is that?
Well, a worker can literally just grab the robotic arm, manually guide it to the starting position, press a button to log a waypoint, guide it to the finishing position, and press the button again. The machine learns the movement physically.
Are you serious? That's incredible.
Yeah, you are taking the floor worker's innate knowledge of the manufacturing process because they know exactly how the part needs to be handled, and you're just giving them a simple tool to automate it themselves.
That completely bridges the gap. You aren't replacing the worker's knowledge at all. You're just replacing their muscle.
Exactly.
So how much of a game changer is it to offer a job as a robot supervisor rather than a manual laborer when a facility is trying to recruit new talent right now?
It is a total paradigm shift for recruiting. Triple automation solutions allow companies to elevate their staff. A worker transitions from being a manual laborer to managing the strategy of the production line.
That's a huge upgrade.
It is. They oversee the quality control and they program the cobots for new tasks. A facility is basically offering a career path with upward mobility and high-tech skill development rather than a path that just leads to physical exhaustion.
And I mean, recruiting, hiring, and training new staff constantly because of high turnover, that's a massive hidden drain on a company's finances.
Oh, definitely.
If you can keep your best people by giving them better tools, that workforce stability is a massive financial return all on its own.
Exactly. And when you combine all these factors, the true math of automation becomes clear. You stop looking solely at that hourly wage offset.
Right.
You zoom out and you combine the drastically reduced raw material waste, the fenceless real estate efficiency, the increased throughput from the ghost shifts, and the massive savings from workforce stability and lowered injury rates.
It just completely rewrites the equation.
It does. The white paper notes that when you factor in all those multi-layered benefits,